continue with this. So last time we talked about case one of rational functions, and case one was that the polynomials in the numerator and denominator have the same degree, right? So here we had 2x and x, or it's like x squared over x squared, and that affects the horizontal asymptote because then you just look at the coefficients of the terms. All right, so let's look at case two. This is where the degree in the denominator is greater than the degree of the numerator, all right? And in this case, the horizontal asymptote is always y equals 0. That's it. It's just as simple as that, okay? All right, so we're going to do the same thing here. And again, you always go through the same steps. Find the zeros, find the vertical asymptote, find the horizontal asymptote, pick a couple of cute little points and graph. All right, so let's do that. First, let's find the zeros. For this, I've got a little hint for you. We're going to set the numerator equal to 0. All right, so in this case, what's my numerator? 5. When you say 5 equals 0, when does it? Never. 5 never equals 0. That means this function has no zeros. F of x has no zeros. What does that mean about how it looks? Right, it's either above or below. It never crosses the x-axis. How weird is that? Okay, now we want vertical asymptotes. For these, you need to set the terms of the denominator which don't cancel. Okay? So, the first thing I do when I see a rational function is I try to factor it. So here we have 5 over, what's the denominator going to factor to? There you go, x minus 1, right? X plus 5, x minus 1. Now, does anything in the numerator cancel with anything in the denominator? No. Okay, that stuff in the denominator, right, is there for good. That stuff's not going anywhere. Because they don't cancel, they give us vertical asymptotes. Okay? So, set x plus 5 equal to 0, x minus 1 equal to 0. So let's just put a note here. These don't cancel, which means they give us vertical asymptotes. Okay, VA is my vertical asymptote symbol. Okay, all right, so x equals -5 and x equals 1. Those are my vertical asymptotes. So I go to -5 and 1. Oh my gosh, we have 3 regions, 2 vertical asymptotes. Holy moly. Okay, horizontal asymptotes. What do you think? The degree in the numerator is lower, the degree in the denominator is higher, so horizontal asymptote is just y equals 0. Yes, so just a sec. So higher degree in denominator. Okay, so at y equals 0, I've got a horizontal asymptote. Correct. The degree is the exponent of the variable. Okay, so my asymptote is at y equals 0, and that's actually like the x-axis. And in order for it to show, I just put it like a hair above, but you've been doing that forever for the exponential graphs, so we're good at drawing those. Okay, now I'm in a bind. Because before, I would have a 0 somewhere, and I would use that to guide me whether, something was above or below. Okay, what am I going to do now? I don't know what to do now. You tell me, what should we do? You can make a table of values. I like table of values. Guess what my favorite number is to plug into a function? 0 is really my favorite number. So x, f of x, what was f of x? 5 over x plus 5 x minus 1. You could use any form of the function you like. I like the factored form because it's easier for me to do the calculations. So when x is 0, y is 5 over 0 plus 5 is 5. 0 minus 1 is negative 1. So that's negative 1. Okay. Can I plug x equals 1 in there?
No.
Why not?
Because
That's a horizontal, that's a vertical asymptote and nothing works there. What other number you want to plug in?
-3.
What did you say? 2 and negative 3. Okay, let's do negative 3 first and then we're going to do a 2. Let's do negative 3. Y equals 5 over negative 3 plus 5 is 2. Negative 3 minus 1 is negative 4. So 5 over negative 8. Negative 5 over 8. And now, oh my gosh, like suppose you don't have your calculator with you. Oh my gosh, do I panic? Do I panic? Do I panic? No, because roughly I know where that is. Where is that? Negative 3 and negative 5 over 8. So it's somewhere over there. Okay? Now, how about if we do another one? Well, what did we say, Ethan? You said 2. Let's do 2. Positive 2. So we have 7 and 1. Okay, so 5/7 here. Okay, so now let's take a look at, let's just, you know what, we could keep plugging points in all day long, but let's just think about this for a minute. Okay, this function has got to follow the vertical asymptotes on the ends here, right? Now, is it allowed to cross the x-axis?
No.
Is it?
No.
Why not? Because it has no zeros. It has nothing to do with the horizontal asymptote. It has no zeros. So that means here on the bottom, it's got to follow, it's going to live on the bottom, right? Because these 2 points are on the bottom. So we know it's going to cross the asymptote, the axis there. I'm sorry, it's going to follow the asymptote there. And so, okay, so it's going to come up here like this and then hit that point. And where do you think it has to go from there?
Is it like Pac-Man?
Is it gonna, it's gonna end up like Pac-Man. But okay, so now here's my question for you. Is this gonna keep going up like this? Why not? No zeros, it can't cross the x-axis. But it's gotta follow vertically that asymptote on the left somehow, so where? So it could go down. One option is this thing could just go down like that. Okay, let's see if that works. Let's plug in negative 4. What does negative 4 get us? 5 over 1, negative 5. What is it? Negative 1. So at x equals negative 4, it's negative 1. Look, it actually did come back down, just like we predicted. Tell me that's not cool, right? So now it comes down here. Now, here's where Pac-Man comes in. Once you're done with a region, you can do the Pac-Man thing. If it exited the screen on the bottom to the left of the asymptote, what's it going to do? Come in to the right from top? We already know that because we had put in a point and we said it was going to cross that. Okay? So look, this one on the right side, it comes in from the top, and now here it's got to turn back around because no zeros can't cross the x-axis. Okay, what about on this left side? It left the screen to the bottom on the right-hand side of the asymptote. It's got to re-enter from here, and it's going to look like this. Okay? Yes. All right. So let's take a look at this one and see which case this is going to fall under. So, all right. Find the zeros. We're going to set the numerator equal to 0. Okay, x equals -1. This does have a 0. So when I go here at -1, there's a 0. Vertical asymptotes. Okay, so first let's factor. Yes. Let's factor, and I'm going to get x plus 1 over x plus 6 and x minus 2. Did anything cancel? No, which means both of those give us vertical asymptotes, okay? So x plus 6 equal to 0, x minus 2 equal to 0. X is -6, x is 2. Let's go ahead and put those in now. X is 2, x is -6. For the horizontal asymptotes, I have to compare the degrees from the top and the bottom, the terms with the highest exponent from the top and the bottom. For that, I go to my original function, and I'm going to compare that with that. All right, where is the higher exponent? The bottom. So what's the horizontal asymptote? Y equals 0. Okay, so here y equals 0 right there. Huh? Yeah. Right, when the denominator has a higher degree. That's case, next case. There is no horizontal asymptote there. Okay, so now let's graph this guy. Okay, look at what happened. There is a 0, and the 0 is on the actual horizontal asymptote. Can a graph cross the horizontal asymptote? Yes, it can. Can it cross the vertical asymptote? No, it can't. Okay, so now when I'm looking at this, I know that, there has to be some asymptote following, right? Here or here, right? So the way I see this is my graph, yeah. Okay, exactly. So before we do that, the way I see this is, one way my graph can look is this, right? Because it's got to follow the horizontal asymptote on top somewhere and on the bottom somewhere. What's another way that line could look? The opposite way, like this. To figure out which of those it is, we're going to pick a test point. Okay, so let's pick a point. So x, we could do 0. And then f of x was x plus 1 over x plus 6, x minus 2. So when I put in 0, I have 1 on top, 6 times -2 on the bottom. How much is that? -1 over 12, which means it's way over there somewhere. Okay? Just for funsies, let's do -2. If I do -2, what do I have on top? -1 over what on the bottom? 4 and -4. So how much is that? 1/16, and that's a positive 1/16. So right there. Okay, so do you see how it's got to look that way? So now I say it looks like this. There's only what? I don't understand. Oh, yeah, it won't. It's only going to cross the x-axis once, and it's not. These are not those graphs. Those are like complicated ones, like e to the x times sine of x times blah blah blah. We're not. No, we're not. No, not until you get to those when you're like in college. You're old enough to buy a house. You're old, like over there. Okay, now we do our little Pac-Man bit, right? So if it exited from the bottom here, it's got to re-enter from the top. come down, and I know it's got to cross, I know it's got to follow the horizontal asymptote there. Is it going to cross the x-axis anywhere? No, because there are no more zeros. So this is the only way it can look. What about on the left side? Is it going to be on top or on the bottom of the horizontal asymptote? Bottom. It's going to come up and there. Okay? Like, okay, so seriously, would you ever have thought you could look at something like this and graph it without even using your calculator? Like, who would have thought? Look at us now. Look at us. This is why I love teaching Algebra 2, is because there is such a big difference in how much math you know compared, like, from August to June. Like, so much difference in what you can do in math. Yes? Okay, this next one is already factored for you, okay, which is good. One less step. So let's find the zeros again. That's just 2x equal to 0. Vertical asymptotes. Does anything from the denominator cancel? No. So both of those give us vertical asymptotes. Whoops, x minus 5 equals 0. So x equals 5, x equals negative 2. Let's just put those up here. So 0, 5, negative 2. And then what else do we have here? Find the horizontal asymptote. Okay, now here's the trick. This is already factored for us. Remember what I said up here is when I had the function in factored form, to get the vertical asymptotes, we just went to the denominators. But then when I had to do the horizontal asymptote, I said go back to the original function, right? So here, we have to sort of go back to what the original function should have looked like. Now, do you have to multiply out the whole thing? You really don't, okay? There is a shortcut we could do. So this would have looked like, in the numerator, we have 2x. And then for the denominator, all you have to do, for the purposes of the horizontal asymptote, just multiply those two terms together. So here I have x times x. That's 2x over x squared. And that's good enough for my horizontal asymptote. Okay? So now when I compare higher degree on the bottom, what's the horizontal asymptote? Y equals 0. Okay? All right. Now I'm going to give you about like 30 seconds to 60 seconds, 30 seconds to a minute in order to graph this. And I'm going to be walking around to make sure. So I'll stop this recording for a minute. So all I had to do for this one is put in that x equals 1, y equals negative 1 over 6. So when x equals 1, y equals negative 1 over 6. And now I know that it's got to follow the vertical asymptotes to the right and to the left. And if it goes like this here, okay, then there is only one way really for that arm of it to look. So that's what I do first, is that middle one. And then I say, okay, if on the right-hand side it exited on the bottom, then it's got to come back on the top. And then if it exited on the top here, then it's got to come back on the bottom. Okay? All right. So let's do this next one. So this is now case 3. This is now case 3. And case 3 now says, if the degree of the numerator is greater, so if it's got a higher degree on top, then there are no horizontal asymptotes. That's it, no horizontal asymptotes. All right? So let's take a look at this one. What are the zeros here? Right, y equals 0 or none, or it's y equals a number. Right, like the case 1 when the coefficients. We need to take the coefficients. Okay, so for the zeros, it's going to be x squared equals 0. So x equals 0. Okay, vertical asymptotes. Does anything in the denominator cancel? No. I know I keep asking that, and the answer is always no, and you think I'm asking for no reason, but wait till you see the next thing we're going to do next time, and then you'll see why. So x plus 1 equals 0, x equals negative 1. So at x equals negative 1, there is a vertical asymptote. Okay, horizontal asymptotes. You go to the original function, compare the degrees. Higher degree on top means no horizontal asymptote, and you just say none. Okay? Higher degree in numerator. All right? If you just say none, that's good enough. Now, for this one, we're actually going to use the calculator to graph. All right? Let me turn mine on. Biggest pitfall is students don't put parentheses where you need to. So it's x squared over x plus 1 in parentheses. Let's put that in. X squared over x plus 1 in parentheses. And we're going to graph. And that's what it looks like. Oh my goodness. What is that? Huh? Oh, is it okay now? Okay, so look at this one. Do you see the vertical? Well, put it in again. Okay. So you know what? I'm just gonna adjust my windows. I'm gonna do 4 window settings, and then for Y min and Y max, I'm gonna go from like -10 to 10. Enter, just so I see a little bit more. Okay, now, I went to menu, number 4 for window, number 1 for settings, and then I just changed Y min and Y max to go from -10 to 10. And you know what? I might actually go a little bit further now that I'm here. Why don't we do -20 and 20? I'm just feeling, you know, like I want to splurge today. Okay? So look at that. Do you see the vertical asymptote here? Do you see how if you look from the top to the bottom, there is a point here where there is no line? Right? So you know what I'm going to do is I'm going to go into f of 2. Where was the vertical asymptote? It was at -1, right? Oh, you know what? It's okay. I won't do it here. So now, okay, look at this asymptote here, right? Is there a horizontal asymptote? There is not a horizontal asymptote. But look, if I were to draw, okay, let's go into here, and I'm just going to draw y equals x. Do you see how at the very ends, right, this follows that red y equals x line? That's actually the asymptote for this graph. It's not a horizontal asymptote. It's what I talked about the other day, oblique or slant asymptote, right? So that's what it looks like. So yes, when the numerator is greater on top, there is no horizontal asymptote, but there can be an oblique asymptote. So you see how it clearly follows that line. Okay, now let's go to what it is that we need to do here. We need to graph that here. Okay, so how am I going to do that? What I do, the best thing for me is you could either go to the table or you could trace. I like tracing because I could put in what I want. So 5, graph trace is number 1. And now, okay, at 0, y is 0. In trace mode, the reason why I like this is you can put in any value. So you could put in, let's say, you could type in 2, and it'll say x equals 2, enter, and it's 1.33. Okay? So when x is 2, it's 1.33. Okay, so in trace mode, you just type in the number that you want. So let's say, okay, I'm going to put in negative 0.5 right there, and it's 0.5 here. Okay, so that kind of gives me a guide on this side, and it looks like this. And then on the opposite side, let's put in like negative 2, and I get negative 4. Let's put in negative 5, and I get negative 6.25. All right. So that's how it looks. And you can trace all the way, you know, as much as you want here, and you could figure out points. So let's see, what is it at that corner? So at that corner, it looks like it's negative 1.7 and negative 4. Okay. All right, so it's going to look like this. Okay. All right, so that's where I'm going to stop. And your homework for next time is going to be this, day 2.